Hello mathematicians, we're now going to have a look at cubic identities. Now for many of you this will be the first piece of new work. Some of you may have encountered some of it, but that's okay. So the first thing, or the first set of identities that we look at are the sums and difference of cubes. So we had a difference of squares. There is no sum of squares that we have to worry about. There is a difference of cubes and there is a sum of cubes. And these are just patterns, I would say, to be learnt. They do turn up on the reference sheet, but I think that you should be capable of learning them anyhow. So just look at a way that you can do it. If it's a cubed plus b cubed, for example, we've got just a plus b out the front, so the sign is the same in here. And then over here, we've got nearly a perfect square. We've got a square of the first one plus a square of the second one and minus. So the fact that it's odd, in a sense, it's different to this sign, is a way of triggering your memory. And the other odd thing is if this was a perfect square, hopefully you're used to it being 2ab in there, and this is not 2ab. So I encourage you to try to do it without flipping back to the reference sheet all the time, but you do have that as a crutch. Now, likewise, a cubed minus b cubed, you've got a minus b out the front, and you've got the almost perfect square, and the signs are different just here. Now, we also have, and these are not on the reference sheet, the result of cubing. So we know how to deal with squares, where we have the square of the first plus or minus twice the product and the square of the second. With cubes, there's simply another pattern. So there are going to be 4 terms. There'll be an a cubed and a b cubed, and the other 2 terms will have a 3 as the coefficient. So just a little bit of background. You may have come across Pascal's triangle at some point, and you will later on in the extension in Year 12. So Pascal's triangle goes like this. We start with a 1, and then another 1 and a 1, and then 1, 2, 1. So if we add this one and this one, we get that one in the middle. And this line gives us the coefficients of the expansion of a square. A squared plus or minus 2ab plus b squared. If we extend that pattern, 1 and 2 is 3, just there. 2 and 1 is 3, just there. And we get a 1 just there. This is the pattern of coefficients in a cube. We could go on and get the coefficients in something raised to the 4th power, 5th power, and so on. And as I said, that will be towards the end of the HSC course. But if you look at the expansion of the cube, first thing is to get those coefficients right. So we've got our 1, 3, 3, 1. And then what happens with the powers? So a is cubed, squared, single power, and then if you like, it's a 0 power because it disappears down here, or it becomes a 1. And the b cubed, or the b, goes in the opposite progression. So it's b to the power of 0, b to the power of 1, b to the power of 2, b cubed. Tedious, and you have to pay attention to detail, but you will get there. If all else fails, of course you can just square it and then multiply all of that by a plus b. Sometimes it's just as quick to do it that way. With our a minus b all cubed, it's exactly the same, but the reason we have a minus here is because we're multiplying by minus b. Over here, minus b squared becomes a plus, but minus b cubed, we still end up with a negative. So let's look at some applications of these. Okay, so let's look at this one. This one is exactly as up above. So we've got this, and we've got a 1, and we've got the minus, but let's actually tack the minus and the 1 together. I'll rub that out so we can actually see the question. But the reason for doing that is that then I'm really just saying it's b plus or minus 1 all cubed. So my coefficients are 1 and 3 and 3 and 1. The first term is this one cubed. Now then I've got this one squared and this one to the power of 1. So a b squared times a minus 1 means that that will be b squared, and minus 1 will just change that sign. And then I've got a b times minus 1 squared. So minus 1 squared becomes plus 1. So my signs are panning out as I expect. And the last term is minus 1 cubed, which will be minus 1 times minus 1 times minus 1. So it will be minus 1. Let's jump to this last one. So I've got a 2x and a 5y to be cubed. So again, I've got a 1, 3, 3, 1 in there. So my very first term, I want 2x all cubed. So that will be 8x cubed. And then I've got 3 lots of, I might need 2 lines here, 3 lots of 2x squared, 2x all squared, sorry, so that's 4x squared, times 1 lot of 5y, plus I've got 3 lots then of 2x times 5y all squared, which will be 25y squared, plus I've got 5y all cubed, which will be 125y cubed. So if I just tidy that up then, I've got 8x cubed plus, so this bit here is 3 4s are 12, 12 5s are 60, x squared y, plus 3 2s are 6, 6 times 25 is 150, xy squared, plus 125y cubed. Long, tedious, messy, and my writing doesn't help. Let's have a look at a couple of the next ones. So here we've got difference of cubes. G is cubed, 1 is cubed. I'll jump to this one just because it's slightly harder. 3 is cubed and t is cubed. So if I think about my difference of cubes, that's a 3 minus a t multiplied by a 3 squared, and the sign is now the opposite of this here, so 3 times t plus t squared. So just learning a pattern for those ones. Now for this one here, it says write as a product of 3 factors. They won't generally spell it out like that, they'll just say factorise this. So when we look at that there, our 81 is a nice square, but it's not a cube. We've got a t cubed there. We've got 2 terms and a t cubed. What we've got to remember is our rule from way back when, that when we're factorising, the very first thing we do is look for common factors. So is there something which will go into 24 and 81? And of course there is, which is 3. So that's 3 outside of 8t cubed minus 27. And when we get it, plus 27. When we get it like that, we can now see that this is a pair of perfect cubes. This is 2t all cubed and this is 3 all cubed. So we've got 3 outside of, and we apply our rule for the cubes. So in our first set of brackets we've got t plus 3, and in here we've got simply t squared and our minus, that oddity. So this is 3 times t, and on the end we've got the 3 squared, which is 9. So that's our product of 3 factors, that, and that. Now finally, before I let you loose on the exercises on this, let's just do this one here. It's a horrible one. It's an addition of fractions and that means we've got to get a common denominator, something that x cubed minus 1 will go into, and that x squared plus x plus 1 will go into. We have to just recognize, so again, you have to be really familiar with this stuff, that x cubed minus 1 could be written as x minus 1 outside of x squared plus plus x plus 1. If we don't see that, we're doomed. So we have to just know our work well enough to be able to do that. When we do, it's pretty straightforward. So this is x cubed minus 1. How many times will x cubed minus 1 go into that? It will of course go once. 1 times 1 is 1. How many times will this bit go into this? Well, it will go x minus 1 times. So x minus 1 will get multiplied by x plus 1. And what I'm hoping is that as you're writing this down, you recognise that this is a difference of squares. So this part here becomes x squared minus 1. Our bottom, now I'll just rewrite this back as x cubed minus 1. Doesn't have to be done that way, but I'm lazy and it looks nicer. So then my numerator, these minus and plus 1s cancel. So I've got x cubed up the top, x squared up the top, and x cubed minus 1 on the bottom. Please do not even think about somehow or other cancelling this with this. It can't be done. We can only cancel things which are multiplied. So if they are separated by a plus or a minus sign, whether it's on the top or the bottom, no cancelling, please. So again, think about what it is that you need to know and commit to memory for this one, and have a go at 1E.